Something strange is happening in robotics. Strange and wildly exciting. 2025 is shaping up to be the year where robots stopped pretending to be useful and actually started working, flying, and adapting to the real world. This isn't just some flashy demo reel with dramatic music, by the way. This is real engineering, real AI, and real deployments. In the time of just weeks, we've witnessed two jaw-dropping milestones. The world's first flying humanoid robot, lifted off using jet engines, and a new generation of intelligent factory robots from China's ROKA Robotics quietly changed industrial automation as we know it. This isn't just about robots becoming more advanced. It's about robots stepping into the human world for real. Iron Cub 3, the world's first flying humanoid. Let's start with what feels like it was pulled straight from a Marvel movie. Iron Cub 3, the world's first real humanoid robot to take flight. Developed by the Italian Institute of Technology, IIT, with a collaboration from Milan Polytechnic and Stanford University. Iron Cub 3 is unlike anything the world has seen. Standing just over 4 feet tall, this robot didn't just hover in a lab. It lifted itself off the ground using 4 mini jet engines in a real-world test. The iCub robot that IIT's Humanoid is based on is childlike in both appearance and even size. It measures 3 feet, 1 meter tall, while weighing 49 pounds, 22 kilograms, and has childlike dimensions, with a baby face, which looks shiny and baby-like. Getting a humanoid robot off the ground is one of those engineering problems people have been calling impossible for decades. You're fighting not just gravity, but heat, fuel efficiency, balance, and control. Now imagine adding legs, arms, sensors, and a head, and asking that robot to stabilize itself in turbulent air. That's exactly what Iron Cub 3 is doing. 4 jet engines, 1,000 newtons of thrust. Iron Cub 3 has 2 jet engines fixed on its back and 1 on each arm, generating over 1,000 newtons of thrust. That's enough to gently hover, not just blast off like a rocket. But here's where things get interesting. It's not just relying on raw power. The robot's AI brain is trained with aerodynamic simulations and wind tunnel data. It's learning how its limbs affect airflow, how to lean, stabilize, and hover, like a drone, but with arms, legs, and balance points. It hovered about 50 centimeters in the air during early testing. Not high, but high enough to prove a huge point. This is an incredible feat in robotics. AI plus robotics equals real mobility. Engineers at IIT are already testing more complex flight maneuvers, and future trials will expand to Genoa Airport in Italy for higher altitude tests. The robot's digital twin, created using tools like PTC Creo and ANSYS Fluent, allows for ongoing virtual testing and real-time simulation feedback. So this is what the result looks like. A robot that's not just reacting, but learning how to fly. It can adjust posture, thrust, and movements based on AI predictions. It's an embodied intelligence system, trained not just to move, but to fly smart. So you might be thinking, why are we building this in the first place? The answer is simple: disaster response. Imagine an earthquake zone. A building has collapsed. Roads are blocked. You can't send drones because you need someone or something to physically navigate the rubble, assess danger zones, and fly over hazards. Think of it like the new Spider-Man, but humanoid. That's what Iron Cub 3 could do. Walk where needed, scan with sensors, fly when possible, and relay life-saving data. All of this is without risking human lives. Meanwhile, in China, ROKA is solving automation. While Iron Cub 3 is rewriting robotic mobility, China's ROKA Robotics is quietly addressing one of the most boring and important problems in modern manufacturing: the last mile. You've heard the phrase in logistics, but what is the last mile? In robotics, the last mile is that final, unpredictable part of a process where humans are still needed. Whether it's placing a fragile object just right or adapting to a messy, imperfect work environment, traditional robots usually fail this part. That's exactly what ROKA's new generation of embodied AI robots are designed to fix. smarter, not flashier. ROKA isn't focused on humanoid aesthetics. Their new robots might not look like people, but they act like smart, efficient coworkers. They're built with contextual intelligence, not just sensors that scan the environment, but AI that understands it. In a warehouse with bad lighting, misaligned packages, and haphazard labels, a traditional robot might freeze or simply make errors. ROKA's new AI robots can adjust their behavior on the fly, just like a human worker would. These robots have advanced vision systems, multimodal perception, and task reasoning models trained to handle variability, autonomously correct errors, and even collaborate with humans when needed. This is the opposite of rigid automation. It's intelligent, flexible deployment that adapts to real-life unpredictability. Why is this a big deal in manufacturing? In manufacturing, you can automate 90% of a process: welding, lifting, sorting, but that final 10% is actually just really hard to program. It often involves subtle judgment, balance, or dexterity that's hard to describe in a humanoid. That's where ROKA's Embodied AI comes in. Their new robots aren't programmed in the traditional sense. They're trained using reinforcement learning, computer vision, and interaction modeling. Thus, these robots can recognize when to switch tactics. And it's not just in theory. These robots are already being deployed in real-world factories across China and beyond. While the Western world is concerned with the perfection of humanoid aesthetics, China is focused on function and workability. ROKA is also positioning itself as a leader in modular industrial AI, offering robotic arms, mobile units, and customized hardware packages that can integrate into any facility with minimal adaptation. Embodied intelligence is finally here. What Iron Cub 3 and ROKA's new systems both share is embodied intelligence, AI that's not just trapped in a chatbot or behind a screen. These systems are physically interacting with the world. They perceive, adapt, and respond like humans do. This means they can adapt in motion, in space, and in real time. And it's not just about innovation, it's about necessity. In aging societies, robots like these could keep economies moving. In disaster zones, they could save lives. In logistics and manufacturing, they could eliminate bottlenecks and make industries resilient. The flying robot grabs headlines, that's for sure. The factory AI solves problems. What people are saying. Iron Cub 3 is a mind blower. We've been dreaming about humanoid flight for 30 years. Now it's real. ROKA's new bots will do the job of 5 workers in half the time. No burnout, no retraining, just results. It's Astro Boy, but they need to fix the hair. The shift to embodied AI is everything. Intelligence without a body was step 1, this is step 2. This is only the beginning. Here's the thing, these 2 robots, Iron Cub 3 and ROKA's AI workers, might seem unrelated at first glance. One flies, one works in factories. But both are solving physical problems with real-world intelligence. They represent the 2 ends of the robotics spectrum, mobility and accessibility, Iron Cub 3. How can robots go where we can't? Adaptability and productivity, ROKA. How can robots work like we do? 2025 may just be the year where robots stopped being experimental and started being operational. What are your thoughts? Let me know in the comments below, and don't forget to subscribe for more info on AI, robots, and new technology.